Hello all. Now let's see some of the problems relating to the inverse Laplace transform. So our first problem is find the inverse Laplace transform of 1 by s plus 1 whole square. That is, the given x of s is 1 by s plus 1 whole square. So we know that e raised to minus 80, it has got the Laplace transform of the form 1 by s plus a. So here the value of a will be 1 because it is s plus 1 means it has the form 1 by s plus a. That is, its inverse Laplace transform will be e raised to minus 80 where a's value is 1. Therefore 1 by s plus 1 whole square, it will have the inverse Laplace transform that contains the term e raised to minus t. So x of t will be e raised to minus t Laplace transform of 1 by s square. We know that the inverse Laplace transform of 1 by s square is nothing but t into u of t. Hence, we can say that 1 by s plus 1 whole square has got the inverse Laplace transform of t into e raised to minus t u of t. So, that is the first problem. Now, moving on to the second problem, we have to find the inverse Laplace transform of x of s is equal to s by s plus 2 whole square. The term s by s plus 2 whole square, its numerator portion can be just rearranged as inverse Laplace transform of s plus 2 minus 2, because 2 and minus 2, it will give the net result of 0 by s plus 2 whole square, and we'll just split the fraction, that is Laplace transform of s plus 2 by s plus 2 whole square minus 2 by s plus 2 whole square. We will find both these terms separately. S plus 2 by s plus 2 whole square means it is equivalent to 1 by s plus 2 minus 2 by s plus 2. And here again it is of the form 1 by s plus a, and the second term is minus 2 by s plus a. Hence the first term will be having the inverse Laplace transform of e raised to minus 2t u of t, and the second term it will be having the inverse Laplace transform of minus 2t e raised to minus 2t u of t, because it is 1 by s square form that is coming in the denominator of the second term. So t will be also there, minus 2t e raised to minus 2t u of t. Hence on combining both, we will get the final x of t, that is the inverse Laplace transform as e raised to minus 2t u of t minus 2t into e raised to minus 2t u of t. We will take e raised to minus 2t outside, and we will get 1 minus 2t into e raised to minus 2t u of t as the final inverse Laplace transform of s by s plus 2 whole square. Hope it's clear. Just that we are adding and subtracting plus 2 and minus 2. We are splitting it into two parts, and we are taking the inverse Laplace transform separately. Now, moving on to next problem, we have to find out the inverse Laplace transform of s by s plus 2 whole square plus 1. Where x of s is s by s plus 2 whole square plus 1. Again in this case also, in the numerator we are adding and subtracting 2 so that we get it in a standard form. We will take the inverse Laplace transform of s plus 2 minus 2 by s plus 2 whole square plus 1. And we will split it into 2, that is s plus 2 by s plus 2 whole square plus 1 is taken as the first term, and in the second term we will take the minus 2 outside, and the rest of the term, that is 1 by s plus 2 whole square plus 1, it is kept inside the bracket. Now we will solve the inverse Laplace transform separately for the second as well as the first term. For the first term, as there is an s plus 2 term, it's clear that it will contribute to a term e raised to minus 2t. That is by shifting property, and e raised to minus 2t is taken outside. Then the only term that we have to find the inverse Laplace transform is that shifting component is removed, that is s plus 2, it will contribute to e raised to minus 2t. So in the next step you need not write s plus 2, you just need to write the s terms. So e raised to minus 2t Laplace inverse Laplace transform of s by s square plus 1 minus 2 into, again in the second term also there is s plus 2 whole square term in the denominator, so it will also contribute to e raised to minus 2t term, inverse Laplace transform of 1 by s square plus 1. So Next step, we need to find out the inverse Laplace transform of s by s square plus 1. That is actually the standard form of cos omega t. Here omega is equal to 1. Hence, first term's inverse Laplace transform is e raised to minus 2t cos t. And the second term's inverse Laplace transform is minus 2 into e raised to minus 2t sin t. Because sin omega t's general form for Laplace transform is omega by s square plus omega square. So here omega is equal to 1, and hence we can say that the total inverse Laplace transform is e raised to minus 2t cos t minus 2 into e raised to minus 2t sin t whole into u of t. Okay. Now the next problem, that is s by 2 into s square minus 8. So that is your x of s. We will have a small rearrangement here. We will take the 2 term outside. Hence the x of s becomes 1 by 2 into s by s square minus 4. We know that 4 is nothing but 2 square. So it can be again rewritten as half into s by s square minus 2 square. So we know that the hyperbolic cosine function cos h omega t has got the Laplace transform s by s square minus omega square. In our case, omega is 2. So s by s square minus 2 square will be having the inverse Laplace transform of cos h 2t, because here omega is 2. Therefore x of t is nothing but half into cos h 2t. Because inside the bracket, just see the first line, it is half into s by s square minus 2 square. That s by s square minus 2 square is nothing but cos h 2t, and the half you have to write it again. So x of t, that is inverse Laplace transformed version, is half into cos h 2t. Now moving on to the next problem, find the inverse Laplace transform of x of s is equal to 2s plus 1 by s plus 2. Again it might be done by a small rearrangement. We can write the one term in the numerator as 4 minus 3. 4 minus 3 is again 1. So x of s may be rewritten as 2s plus 4 minus 3 by s plus 2. From 2s plus 4 we will take 2 outside and we will make it the first term. That is 2 into s plus 2 by s plus 2 is the first term, minus 3 by s plus 2 may be taken as the second term. From the first term, s plus 2's will get cancelled. So it becomes 2 minus 3 by s plus 2. We know the inverse Laplace transform of a constant is constant into delta of t. So 2's inverse Laplace transform is 2 into delta of t minus 3 into, again s plus 2 is coming, so it becomes e raised to minus 2t into u of t. So that is your inverse Laplace transform. For x of s is equal to 2s plus 1, we get x of t is equal to 2 into delta of t minus 3 into e raised to minus 2t u of t. Now moving on to the next problem, x of s is equal to s plus 1 by s plus 1 whole square plus 4. X of s is equal to s plus 1 by s plus 1 whole square plus 4. So inverse Laplace transform, we may find it like this. S plus 1 term is there, it means there is a shifting of minus 1 occurring. So e raised to minus t into inverse Laplace transform of, we need to find out of s by s plus s by s square plus 2 square. We know that inverse Laplace transform of s by s square plus omega square is nothing but cos omega t. Here omega is equal to 2. Hence we get the total inverse Laplace transform. X of t is equal to e raised to minus t into cos 2t into u of t. So these are some of the basic problem that utilize the shifting property as well as the Laplace transform of some of the standard functions. In the next section, we will be dealing with finding the inverse Laplace transform using the partial fraction method. That's all. Thank you.